So we'll start with introduction to the cloud computing. We'll see cloud introduction and overview, then cloud computing technologies, hardware and software infrastructure, different clouds, risk, cloud services, applications and regulatory issues and limitations. First is cloud introduction and overview. So cloud model are being defined as like the model which is on demand and basically for sharing the configurable resources over network, server, storage, applications, and services that could be rapidly provisioned and released with the minimal effort for service provider interaction. So this is being first definition, a model for enabling convenient on-demand network access to a shared pool of configurable computing resource, example, network server, storage, applications, and services that can be rapidly provisioned and released with minimal management effort or service provider interaction. So this is definition given by the National Institute of Standard and Technology. Then there is another definition even earlier to that, a large-scale distributed system paradigm that is driven by economies of scale in which pool of abstracted, virtualized, dynamic scale and managed computing resource power, storage platform and services are delivered on demand to external customers over the internet. So basically, these are the two fundamental definitions. Both are somewhat similar to each other. First is more standard towards what is actually cloud computing look like today, and second one is mostly related to the distributed computing moved towards the cloud and grid computing. And both the things said that the fundamental technologies like network, server, storage, and services, all these things are earlier existing. Then, uh, then there are three basic layers: application, platform, and infrastructure. So cloud computing is basically developed after utility and grid computing. So these technologies, grid and utility, are now converted to cloud computing. So cloud are the three types: public, private, and hybrid, creating a group of scalable hardware and software that allow remote computation, data storage, and access using services. So this is the fundamental thought behind developing cloud computing that can create that that some scalable hardware or software is accessible remotely for data storage and applications. This was the fundamental basic behind the cloud computing. And whether cloud stands on the existing technologies. Yes, this is important that cloud computing exists based upon earlier technologies like hypervisor, virtualization, load balancing, virtual private networks, storage area networks, service-oriented architecture, web services, and many more other technologies behind cloud. So these technologies are actually being developed for ge- generating a new kind of stack or layer, that is cloud computing. Then what Larry Ellison, CEO of Oracle, said, we have redefined cloud computing to include everything that we already do, change the wording of some over our ads. So these are actually existing. That's what Larry said. And we are just redefining all these terminologies. Then Richard said, who's founder of Free Software Foundation, it's marketing hype. Somebody is saying this is inevitable and it's very likely to be said business campaigning to make it true. So Richard said that we are actually doing marketing based upon the old technologies that are being remodeled as new technologies, and we are doing it for the business purpose. An overview of the cloud computing, that cloud computing in the computer science is an analogous to the electrical grid over a electric network. So in electrical energy engineering, there's terminology electric grid and for electric network. So this is the same way cloud computing is analogous to that. Then the concept of convergent infrastructure and shared services. it is based upon the shared infrastructure and shared services. Then maximizing the effectiveness of shared resources. This cloud computing feature will actually maximize the effectiveness of sharing of resources like infrastructure applications. Then resources are shared by multiple users. Means multiple users could share and work on the single document or single file system, and then resource are dynamically relocated as per demand. So these resources could be moved from one city to another, one location to another, and these features could be used based upon different cities. Efficient use of cloud computing power, thus being eco-friendly. So actually using it for the single data center and efficient usage of energy like air condition and rack space, it will be more efficient. Then multiple users can work on a machine. So multiple users can work on single machines so that they can have a single thought for what they have to do. Then user can retrieve and update the data with flexible license for different applications. So licensing could be flexible based upon if they are using single cloud service. So that cloud service vendor will actually combine all the licensing of earlier softwares. Then there is actually uh, capex and opex. So capex is basically uh, purchasing hardware over the period of time. So we actually purchase some of the hardware softwares over the time, and opex is actually operating cost for the purchased infrastructure. So CapEx model said buy the dedicated hardware over a period of time. You keep on buying some of the hardware and software and use it. Then OPEX said use shared cloud infrastructure and pay as one uses it. So OPEX said, cloud computing said that you use some of the cloud infrastructure and software and you pay only for the amount that you use. So now situation is like pe- people, organization and institutes are moving from capex to opex. Means they these organizations are thinking that instead of buying some more resources, we should use some of the cloud infrastructure resources and pay for only the resource that we had used. Then businesses in profit. So opex is nowadays is more weightage as compared to the capex. Opex having more weightage over capex. Then CapEx to OpEx, how it has been moved, the benefit of OpEx and why cloud. So this is all dependent on a benefit of OpEx and sharing. The reason behind is benefit of OpEx. Sharing of resources is possible with cloud to achieve the coherence and economics of scale. Avoid upfront infrastructure cost means sudden if there is sudden spike of usage by the employees or the institute member, then the this will avoid the increment of hardware resources required. Then focus on the code development instead of infrastructure. So cloud computing is majorly based upon the better development of softwares in the back end rather than thinking of developing more infrastructure. So more focus in cloud computing is towards software development. Application can run faster with improved manageability and less maintenance and enable IT. So application could be faster if there is backend server and we have to focus less for the infrastructure development and we have to focus more towards the software code development. Thus, this application could run faster because the infrastructure would be larger, maintained by the large cloud computing service provider. And this will improve the manageability, means we don't have to bother about the infrastructure in the back end of cloud. And because that cloud was provided by some provider vendor, and then we have to less manage those hardware and we'll have better enabled IT. Then adjustment with the fluctuating and unpredictable business demand means sudden customer for an organization is increasing. Thus, it is responsibility of the backend cloud provider to manage the large number of users. For example, Akamai is the company who stores and manages the images and videos and other documents of Facebook. So Facebook is dependent on the Akamai. Akamai is the main cloud provider and where Facebook stores most of its data. So if the number of customer of Facebook is increasing, then it's responsibility of Akamai to suddenly provide the resources demanded by the customers, like images or videos. Then cloud provider use pay as you go model. Charges may be high if administrator do not use cloud. So cloud computing would be pay as you go model, and the as much as user is using, that's the amount that actually been given to the cloud provider. And if administrator is not using cloud, then the cost would be high because the more more software licensing should be purchased, more hardware should required to be purchased. That could be reduced if we go for pay as you go model. Then reason for growth of the cloud computing are basically availability of high capacity network. Why cloud computing has came up after 2010? Because the network facilities are being increased and high capacity of networks are there and low cost computers are there. So cost of the computing resources are reduced after 2010 significantly. Thus, cloud computing has become better. Then storage device cost is also reduced. So data centers can make a large data center with huge amount of storage capacity. Then hardware virtualization softwares are being possible. So softwares developer had developed hardware virtualizations, and then service oriented architecture and utility computing has been evolved and been improved. Thus cloud computing came up. Then result, cloud vendors are experiencing high growth rate annually. So cloud vendors are actually having huge demand every day because of these all benefits. Then history, origin of the term is unclear. So cloud is basically metaphor of internet. Thus, its origin we don't know because internet was earlier also said to be cloud. In 1950s, large-scale mainframe computers practicing a CPU sharing on a mainframe became known in the industry as the time sharing. So if cloud computing is saying that they are providing sharing, so in 1950s also we know that industry says a time sharing of CPU. So mainframe computers are having larger size as well, like data centers. So it is all been existing since 1950s. So still we can't say in 1950s cloud computing was not there. And in mid 70s also, there's time sharing popular for remote job processing or remote procedure call. All these are famous since 70s. So these remote procedure calls are basically behind the services, web services or cloud services. So we in even in mid 70s we can't say that cloud computing was not there. Then earlier, since 1990s, tele telecommunication companies provided point-to-point data circuits, virtual private network. So even at that time, we have virtual private network, efficient bandwidths, big servers, network infrastructure, all were there since 1990s. And scientists, technologies need for large scale computing through time sharing. So all these time sharing was also since 1990s. And then codes of optimize the infrastructure. So backend infrastructure could be optimized through some of the codes. These things are also existing since 1990s. Then better operating system platforms and applications to priorities. prioritize CPU. So these are things developed since 1990s. Then after 2000, earlier 2008, Eucalyptus, Amazon Web Service, Open Nebula, and quality of service like things came up, which are actually based upon these things since 1990s and since the origin of the large mainframe computers. And all these things mean large mainframe computers, CPU, time sharing, and remote procedure call, remote job entry. These are being converted, and then virtual private network, efficient bandwidth, large network infrastructure, time sharing, code optimization, operate better operating system, CPU are being evolved to make Eucalyptus as first open source infrastructure as a service for cloud computing. Then Amazon Web Service as an API for developing private cloud. Then Open Nebula is also one of the first kind of open source deploying private and hybrid cloud, and then quality of service that guarantees cloud based upon infrastructure. So these are things evolved like this. And in 2006, Amazon have Elastic Compute Cloud. In 2010, Rackspace Hosting and NASA jointly launched OpenStack as the cloud platform. Then in March 1st, 2011, IBM started Cloud Framework to support a Smarter Planet project. And then in June 2011, Oracle developed an Oracle cloud-based system and which are being available. And then in 2013, Leslie Lamport got the award of ACM Turing based upon the based upon the work he did for distributed system for time sharing of processors, which has been published in 1978 for time clock and ordering of event in the distributed system, and most cited article in the history. Then Turing Award is one of the best awards in computer science, and it has said that ACM said that Turing Award for imposing clear, well-defined coherence on the seemingly chaotic behavior of distributed system in which several autonomous computers communicate with each other by passing messages. So this is the reason why ACM had given Turing Award to Leslie Lamport, because Leslie Lamport has devised important algorithm and developed formal modeling and verification protocol that improve the quality of the real distributed system. This is the basic for what he got the Turing Award. Then these contributions have resulted in improved correctness, performance, and reliability of the computer. These are the reasons behind what Leslie Lamport got the Turing Award in 2013. Then Google Vice President said that with the growth of growing shift to the ever large scale distributed system and cloud computing, Leslie Lamport work has taken on the significant increased role. So this is the upgradation did by the work of Leslie Lamport and for the newer large scale distributed system. His results has benefited many researcher communities, including those in the parallel and high performance computing, concurrent algorithms, software reliability. So who are being benefited? Concurrent algorithm developers, high performance computing researchers, and software reliability developers. All these stakeholders are being benefited. And this is also means helpful for theoretical community and engineers and programmers who designed and implemented many type of systems. So these are being words of Google Vice President for the Turing Award in 2013. Then Harry of Microsoft said that appreciate the incredible contribution of his work made to our industry, especially in cloud computing and distributed system. So he said that distributed computing and cloud computing is now being developed because of the invention did by the Leslie Lamport earlier for the paper he had written in 1978 and applied. All these technologies are being applied in the distributed system that we still use today. So these are the basic reason why such large awards are being given. Then we'll see the cloud computing technologies like software as a service. The technologies that had involved in cloud computing are like software as a service, inexpensive storage. We'll see inexpensive and plenty client CPU bandwidth to support significant client computation. The bandwidth of CPU for usage of the network is one of the most important feature, and this has to be very less cost consuming. Then sophisticated cloud algorithm for the client that that are majorly dependent on HTML, CSS, Ajax, RESTful services. So these are things being evolution of cloud. Then client broadband bands. So nowadays the large amount of internet bandwidths are there. So this is the reason why cloud is here. Then service oriented architecture is one of the fundamental technologies behind the cloud computing. Then large infrastructure implementation from Google, Yahoo, Amazon, and other real world and massive scale distributed computing. So these are the companies who had actually invested and developed large scale infrastructure for the client. And this is one of the also reason for the cloud computing technology now we are seeing. The commercial virtualization means virtualization of hardware to be provided for the user's client. So these are the reasons. Cloud computing is upgraded version of grid computing, utility computing, or distributed computing. And these are the technology behind the cloud. Cloud has evolved by addressing quality of service and reliability problem. User could be now be better safe with a legal agreement for quality of service. Then cloud computing provider the tools and technologies to build data compute intensive parallel applications. Now cloud computing provides remotely available applications for data and computation in parallel to the other users and with the help of parallel applications. So these are the technologies behind cloud computing. So the technologies are like supercomputers. We know that large size of computers are behind this, and now they are being mostly said as data centers. Then grid computing, that multiple computers are being connected together to make it as a grid. Then utility computing, which is based upon pay as you go computing, and that illusion for the large scale, large size of infinite resources are there, are the basic concept of utility computing that are being further being improved for cloud computing. Then demanded billing likely are daily on user basis. So these are the fundamental billing criteria for utility computing. Based upon hourly, they are billing the customer. They are billing based upon the number of users, number of usage daily basis. And these billing models is now came up on the cloud computing. Then software as a service came up, and these software as a service actually being become the part of cloud computing terminologies. And then hardware platform, software as a service, all these things are now the part of terminologies in cloud computing. Then virtualization and services are the basic behind the cloud computing. So cloud computing is the combination of the existing technologies. Users can use this combination without the technical knowledge or expertise. So cloud computing uses existing technologies, and users do not need to know about these earlier technologies, and they can use it for with better user friendliness. And the two basic models are virtualization being used and service oriented architecture is being used for providing cloud services and cloud infrastructure. So what is virtualization? It is the process of creating an illusion of the physical computing device into one or more low configuration virtual device such that they can be easily used and managed. So it is like virtualization means virtually thinking something is happening. There is a large data center available, and in the large data center, if some partial amount of hardware resources like secondary storage and the like RAM and the device for storage is being provided to the user, and this has been kept as an image in the operating system. This is what is virtualization of the large hardware data center. Means a small part of that data center is being provided to you as a virtualized. You are getting a small amount of that server, and this is virtualization. It's like illusion of physical computing device. Means you are feeling that you are using only 64 GB RAM of a large data center. Large data center may have more than 1000 GB of RAM, but you are thinking that you are using 64 GB of RAM. So this is what is virtualization. You are thinking that you are using 10 terabyte of hard disk, but actually that data center have 100 terabytes of hard disk, and they have the capability of storing 100 terabytes, but you are using only 10 terabytes, and this is called virtualization. And that is being managed and operated with the cloud computing. Then how it is being done? Service oriented architecture is the basically software programming model which works for this type of virtualization. The cloud computing adopts concept of service oriented architecture that to create service for the sub problems, and these services can be integrated to solve the problems. Moreover, these services are further divided into individual operations procedures. So service oriented architecture are based upon remote procedure calls or web services that actually provide sub problems, means sub feature of internet properties, and these sub feature of internet properties are combined together and set for the integrated solution, that is service oriented architecture. And then these individual service are further divided into multiple operations, means multiple procedures methods are there. Then these are the basic fundamental behind the cloud computing, virtualization and service oriented architecture. Then cloud computing provides its resources in the form of services. So cloud computing provides its resources like infrastructure, operating system, and applications in the form of services. Means services are being provided to the client users. What are the behind that service? That is hardware and software. Use the well-established technologies domain like SOA and virtualization. That's what we are discussing. That these SOA and virtualization are the well-developed technologies, and these two are the behind cloud computing. This result in the globalized and user-friendly technologies. That is being the part of cloud computing. So both SOA and virtualization create user friendliness for the cloud computing user. Then other relevant technologies are mainframe computers, that powerful computers used for critical applications for bulk data processing. So these large size of mainframe computer are being used for bulk data processing. Peer-to-peer communication like distributed architecture without central coordination. So one-to-one connection is there. Then participant for both supplier and consumer of the resource, in contrast to the traditional client and server models, are being combined together. Then grid computing, like like cluster creation of different computers through the network. Computers are composed into a cluster using network. Means different computers are being combined together as a cluster, and this cluster is actually acting as a converged resource, means a single resource. It is that multiple computers are behaving like a single computer. Then utility computing, the package of utility computing resources like CPU and storage are stored according to the pay as you go model. So this is the basic behind the utility computing. Then service oriented architecture. Service oriented computing is the fundamental computing behind the organizing and utilizing distributed services offered by different owners. It gives a formal way of offering different discover interaction with flexibility to orchestration according to the requirement. So these things are being evolved, that peer-to-peer computing, that to the grid computing, and then utility computing, then service-oriented computing for software as a service, and then cloud computing came up. So this is the fundamental technologies behind all the cloud computing that we are seeing. Like distributed services are being provided by service-oriented computing that offers orchestration, means combination of different services together, and all these things will combine to form cloud computing. Then what are software and hardware infrastructure? Are we talking about 10 CPUs, 100 CPUs? No, we are even talking about hundreds of nodes which are containing hundred thousands of CPU working together, and 36,000 computers are being working together. 4,000 nodes are there for the largest, one of the biggest cluster, like each having 16 GB RAM, 4 cross 1 terabyte disk, and 2 cross 4 CPU boxes. Then can we develop this in our lab? Yes, with the help of Eucalyptus, OpenStack, OpenNebula, Nimbus, we can install it on our lab. And Google App Engine, we can develop with the help of Google App Engine app. We can develop on Google with the help of Google Web Toolkit. Then how we can deploy? We can deploy it over Google App Engine. Similarly, Ruby on Rails, we can deploy on Engine Yard. Hadoop and Storm are the basic one of the basic form of cloud computing models working together. Then service oriented computing are there. Grid cluster we can develop, and many more things we can develop in our lab. Then data centers are like providing facility used to house computer system and associate components such as telecommunication and storage system. So data center are the back end of the cloud computing that actually stores large amount of data with the help of telecommunication and storage devices. This includes backup of power and redundant data communication and connections, environmental control like air conditioning and fire suppression, and various security devices. So electricity for maintenance of data center, air conditioning, and fire security are all the features are required. And what it does, it also needs security backup. Manual security, biometric securities are required for protecting the data inside the data center. And large data centers are industrial scale operations using as much electricity as a small town. Like large data center actually uses large amount of electricity like a town is using. So it is using so much energy. Thus, all these things are being required to manage in the data center. Then cloud engines, what are the cloud engines? Example of cloud engines, Eucalyptus, OpenStack, Nimbus, OpenNebula, etc. Web services are the most basic fundamental technology behind the cloud computing. What is web service? It is an interoperable machine-to-machine interaction over a network with WSDL using SOAP message and conveyed using HTTP over the network with WSDL using SOAP message, and that conveyed using HTTP with XML standard markup language. So these are the basic model like HTTP protocol, XML standard, and how it has been managed with the help of WSDL and SOAP. So description of a web service in XML. SOAP is actually basically the message being transferred from one place to another with the help of SOAP messages. And how these SOAP messages are being written, these are being written on the XML. And web services are actually interoperable machine to machine communication. What does this mean? Means one machine can communicate with another machine with the help of network, and the technologies behind this is WSDL and SOAP messages. SOAP is written in XML, WSDL is also written in XML, and these been transferred over the HTTP. Then hypervisors, actually used for virtualization. Virtual machines is a software implementation of machine, that is computer that executes programs like physical machine. Then hypervisor, which provides a uniform abstraction of the underlying physical machine. Hypervisor types: type 1, which is bare metal, and type 2, which are being hosted. A physical machine is virtualized, means a program will virtualize that physical machine such that the virtual machine look like that you are working in the real machine. Suppose there is 1000 gigabytes of 1000 GB of RAM is there in large physical machine, but the cloud customer or consumer wants only 16 GB of RAM on its for its machine to pay. So so consumer will only pay for 16 GB RAM. But how that 1000 GB of RAM would look like 16 GB of RAM? So it was done by the special programs, and that special programs will make that 1000 GB of RAM virtualized to be look like 16 GB of RAM, and so that consumer can only work on that 16 GB of RAM. Then hypervisor provides a uniform abstract of the underlying physical machine. So hypervisor is the basic technology which actually does the abstraction of that physical machine. Then hypervisors type, there are two type of hypervisors. Type 1 is bare metal and type 2 is hosted. So what is bare metal? Bare metal directly runs on hardware, and that is basically used for large size of servers. And the example of this is like Hyper-V, Zen server. So these are the hypervisors are operating system loadable. So those hypervisors actually loads operating system on that. Then hosted means hypervisor runs over operating system, means there is a operating system above that you are installing an hypervisor, and that will actually look like a subset of that machine, subset of that operating system. And then example of this is like KVM. The next big data is another cloud computing terminology. Like big data is of two types, like batch and like of real time. Batch is actually when a large size of data is being kept from long time and it is kept as static. This is batch, and that batch can be processed. Means our old kept data is processed from first line to the last line, then it is said to be batch processing. What type of basic file system deals with it? Google file system and Hadoop distributed file system. But there is new type of processing also needs real-time stream processing. When there is large size of streams are coming and you need to process them, and you need results in real time. Thus, you need to have a different type of system and processing. So, what type of system does it support? Storm for the real-time stream processing. And then, what examples of this is when Twitter daily updates the trending tweets, the most used hashtags. So, these are the basic example of this real-time stream processing. And examples of batch processing is simple Google search that we do. Google basically index all the existing HTML pages and web pages, and then it index, and then we search over it. That is batch processing. But Twitter, when daily and every hour keeps on track of their trending topics and trending tweets, so it's the real time processing. That is a Storm. And there are basically three type of cloud: hybrid, private, and public.